The first metallic bells rang some 5,000 years ago near the dawn of the Copper Age. Perhaps inspired by organic gourds and rattles, bells developed independently across several cultures and have adorned our clothing, enlivened ceremonies, and protected livestock for millennia. Hawk bells first appeared in the historical record as early as the 5th century, and within a few hundred years, their use was common throughout the many cultures and regions where the sport was practiced. Today, the science of bell making for falconry may be at its apex, but it remains an arcane and complex art, practiced by a relatively few and dedicated craftspeople. Master falconer Jim Ince specializes in flying falcons at a range of quarries from snipe to ducks. Practicing since the 1960s, Jim has witnessed both the decline and return of the Passage Peregrine, as well as the development of radio telemetry and GPS. His fondness for Tiercel peregrines and merlins reflects the rich but relatively enclosed country of his native southeast Texas. Through it all, the humble hawkbell has been a constant feature of his falconry.
Well, of course, that's all we had to start off with when I started back in the 60s, where there was no telemetry. And so everybody used two bells. And then in the early 70s, we started getting telemetry, and then, that's evolved greatly over the years. I still use one bell and one transmitter because I'm flying mostly Tiercel peregrines that are waiting on over my head in Houston, Texas. And I have to watch where I run because there's a fire ant hill about every 10 feet, and you will end up on your face if you don't watch where you're going. So I like to be able to hear the bird. I know the bird, is up 300 to 500 feet right over my head, and so it helps me a lot.
An engineer by trade, Jim first applied his meticulous eye and steady hand to creating fine hoods for himself and friends. He then challenged himself with bell making, modeling his creations after the style of late German bell maker George Richter.
These are Richter bells, and the beauty of these bells is they're very light, and I think that's what distinguished them from other bells. As Borno used metal that was about 16 thousandths thick, and so they're a little heavier, and that was traditionally what bell makers used and still use. But these are made out of 10 or 12 thousandths thick material, so they're much, much lighter. But with that lighter material, he had to put a reinforcement pad right there at the hinge, which is where the bell always cracks. And so it's a lot of work to put that reinforcement pad on there, which is why most people don't bother to do it. But if you've got a hard-hitting falcon, I've had birds come back with bruised feet from heavy bells, and so I was really determined that this is the type of bell that I wanted to make.
The Archives of Falconry is proud to present this master class with Jim Ince, as he fashions a pair of hawk bells in the distinctive style of George Richter from his workshop in Houston, Texas. Jim will lead us through the steps he takes to cut, shape, join, and finish the bells, and will introduce us to the various tools and techniques required to do the job, many of which have been pioneered by Jim Ince himself. The modern hawkbell has several familiar and essential features: a top and bottom half, joined approximately in the middle, a small handle for attaching the bell to the bird, a clapper to strike the bell from the inside, and a slit to let the sound ring out. To these basic parts, George Richter would add small reinforcement pads that protect the bell from wear. The tools of the trade. We'll start with the materials. Bell metal.
The three materials that I primarily use in bell making are nickel, which is called German silver, and it's what Richter used in his bells. Historically, people used brass or cartridge brass, and this is phosphor bronze. They all make beautiful, beautiful bells.
Clapper metal.
The clappers that I use are just made out of mild steel. This is probably 12-13 mild steel. They're hexagon shaped. Historically, it's what Pete Esborno used in his bells, and I prefer it because it rattles around in the bell. Other people just use a steel ball.
Solder, flux.
I use the Dandix brand, but it's just a silver solder flux, and it allows the solder to stick where you put it. Pro Pickle, which is a caustic material which cleans all the fire scale off of the bell.
Some off-the-shelf, non-custom tools. Some custom tools fashioned by Jim. A blank cutting fixture.
First process in making the bell is to get a bell blank out of the material that you want. And in order to do that, I made the punch out of 01 tool steel, which is heat treated and hardened. And then I just made this, the body out of mild steel. And I cut a slit in here that's 1.5 inches wide, and I use 1.5 inch material. And all of my bells, 7 sizes, can be made out of 1.5 inch wide material. And the bottom part is an iron working die, which the cutter perfectly fits in. It has to be very close tolerance. And then when you stamp it out with this, just use a hammer here and you'll get a bell blank.
A bell half press.
This is a fixture I made to press the bell blanks. And I made it so that it captures the blank down in here and it can't move, and I can put a small amount of pressure on it. And inside I used for each side these type H drill bushings, which come with a nice radius on them. And so I can interchange depending on which bell size I want to be making. So if you've done your bell half correctly, it will come out even all the way around. If there's any slack in your fixture to where the bell blank can move, a lot of times you'll get what I call a horseshoe shape effect.
Probes and sleeves at various sizes.
I make 7 different sizes of bells, and in order to do that, you have to have these probes with the correct radius cut on the end of it. And you have to have sleeves in order to, once you have pressed the bell half, to get the bell half off of the probe. And I have different probes for nickel and for brass or bronze.
A trimming tool.
And as you can see, it's a slide where I put the bell half on here. And this is adjustable screw, and I go in here and with the Dremel grinder, grind it to the correct height.
A crimping tool. Reinforcement pad cutting fixture.
My goal is to make these little reinforcement pads. In order to do that, I'll insert this in here. And I use just a common drill to put in there so I'm not getting a complete circle. I tighten this down. I take my drill out and I use my punch like this. Hammer it out.
slit cutting fixtures.
In order to cut the slit in the bell, you have to have a fixture like this where you can put the bell down in it, and this brass I used to hold it in the waist of the bell so it holds it firmly in place. And then I use this Dremel fixture to cut the slit in the bell.
And finally, a custom fixture designed to hold the bell halves together for soldering. Now that we have our tools and materials, let's get started making bells. Step 1. Making bell blanks. First, Jim cuts the round bell blanks from sheet metal.
I am cutting out some falcon size bell blanks. I made most of my tooling round like this because I could turn it on a lathe. I had access to a lathe where I worked, and so everything was pretty much round because I could turn it on a lathe. It sure beats cutting them out by hand, that's for sure. Alright, I think that's all I'm going to do for now. Getting the burr edges off of these discs because my tooling isn't as accurate as I'd like it to be. Alright, let's go in and now we're gonna anneal these things.
The blanks are then annealed with a propane torch.
How do you know how much to do?
Until they get red hot. I think Husqvarna used to use some kind of heating pad or something he'd put them on. But this seems easy to me. And again, you want to let them air cool. In other words, you don't want to quench them in oil or water or anything. That puts it right back into a hard state.
After the blanks have cooled, we press them into bell-shaped halves.
This is the press that I use to press out the bell halves. I'll take this bell half and I'll capture it and I'll put pressure on it. As I'm pushing it down there, it's captured and it's got pressure on it. And so it makes it come out pretty perfect. So these have cooled off and I'm gonna gather them up. We'll go to the next stage here. Yeah, you have some lubrication, so I use Vaseline. You're not just shoving it through there with no lubrication on it. And it also helps stick on this thing right there. Material is 10 thousandths thick, and I have recessed this 5 thousandths. So when I screw this down, it's got about 5 thousandths of press on there. You can see that it's just holds it right there in the middle. Make sure everything's clean. Put that in there like that. That just guides it in there. Then I put it on this arbor press. And there we go. We got a bell half.
George Richter applied a distinctive design element to the top of his bells, a practice Jim replicates here.
Richter always put these little decorative notches in here. They don't have any function. They're just totally decorative. So I kind of made a template. If I'm going to put those decorative marks on there, I kind of made a template where they should go. I'll have to actually do the indentation after I press them. But this kind of gives me a guide where they should be. Doesn't have to be real accurate. After you punch the bell half, it's hard to find where these are equally spaced out. I often wonder how Richter did this. Probably if you measured the thickness, it would be a little less than 10 thousandths because it's literally has squeezed this. You know, like I said, it's an interference fit, so about a half a thousandths on each side. So I had to machine this thing just perfect so that it would come out like that. I think I can get something else to get this off there. I made a sleeve. It just barely fits over there. Obviously, it's got to be a pretty good fit because that material is so thin. And it just pops right off. So now you got a bell half with hopefully no wrinkles in it.
Step 2. Preparing the bell halves. The bell halves are first trimmed and sanded to precise size.
Trim these things to the right height.
Each of the bell halves.
Each of the bell halves. I've got my male probe here that's exactly like the one I used to cut my bell halves with, except it's about 1,000 smaller in diameter so that the bell half would just slip over it. And then I cut a sleeve that will go in like that.
And you came up with all of this process by yourself?
All by myself. Here's where I originally took all the dimensions off of Richter bells that Carney loaned me. I took all the dimensions, made notes on all of them, and the radiuses and the diameters and everything. And I don't go anywhere without my calipers, so I have. I walked around for 50 years with a pair of inch calipers, and I use those to do that. So without any trimming, this one's about 540 right there. So I know I'm about on target there. So I want to trim this to where it's about 445 thousandths, and then hand sand to about 440 thousandths. So I've got a screw here that I can go in or out and get this trim height right. So I'm going to measure. I want it about I'm going to back this off a little bit. I probably had this, I think the last bells I made were gear size bells. So I want to check this. I don't want to go too deep. If it's too long, I can always trim it down. I can always move the screw and go back and it's one of those things that if you knew how much trouble it would be when you started, you probably never started. I'm at about 455. So I need to back it off a little. I need to make the distance smaller here. Of course, once you got it dialed in, then it's easy.
Once the trim is set, the next bell halves go quickly.
Right on the money, 440. So we got 4 pieces here, two tops and 2 bottoms. We got them trimmed to size. As you can see, though, they would fit together and that would make a bell, but this material is so thin that they're, even if you butt jointed them, it wouldn't last very long because it's very thin metal. So, we've done a lot of work hardening to this thing. We've formed it, we've ground on it, we've done a lot of stuff, so we need to anneal them again.
We anneal the halves with a propane torch. Annealing softens the metal in preparation for the next step.
Get them red hot again. Some of that flaring off you see is probably a little residue from the Vaseline that I used to lubricate them. Burn all that off.
A crimp along the edge of each half creates a waist in the completed bell and allows for a stronger join.
It's the Indian style bell, and you got to have that crimp right there. And that really strengthens the bell, and it really helps to solder it. It's our crimping tool. Yeah, I got this from Vic Hardiswick, this little fixture right here. And I'm not sure what he used it for. I'm not sure he ever got that far, but it became apparent that it would be very useful for this operation. It goes in about 50 thousandths, then I got a 45-degree angle right there. And so that puts that angle on it. I put it in here. I made this so it just barely fit in there with 100 thousandths sticking up, and made this fixture, and then I poured rock hard putty from the bottom so it would cradle it and then make that cradle right there. All you're doing is you're pressing straight in, and then it hits that angle, and because you have annealed it and the metal is now soft again, it goes in 50 thousandths right there, it seats right there. And then what you're doing with the bottom half is you're just pressing it, and it has nowhere to go, so it has to form that angle right there on here, just to make it. I usually put a little Vaseline on there with my finger just to make it slide good. So now you can see it's not closing all the way because it's held off 50 thousandths right there. And then I just put it in this little arbor press right here. Doesn't have to go very far, just a little bit. Crimp. And now you've got a bell half with a bevel on it.
In the last step of preparation, we drill 2 holes for a BWIT holder in the bell's top half.
So let's pick our 2 top bell halves and go drill holes in them. It puts holes in the bells, so when you're doing your soldering together, there's a place for the air to get out. If I didn't do that, I would have to drill a teeny tiny hole somewhere in that bell so the air could get out.
Okay.
Otherwise, it wouldn't work.
Yeah.
Again, I've got my bell half in there. It sticks out just a little. I want to make sure it's good and flat. Top half of the bell, which I've already put the little marks in for these. Like I said, sometimes I do that, sometimes I don't, but these are the top half.
Step 3. Adding the reinforcement pads critical to the Richter design. First, we cut reinforcement pads from scraps of the same metal used for the bell blanks.
I want a semicircle, and I put this in there.
Jim uses a drill bit to offset the metal before punching. This results in a semicircle shape for the reinforcement pad.
I put my drill in there to position where I want this thing. I'm gonna tighten this down. Take the drill out. Put my hardened steel in there. Take a hammer. Voila, I got my half.
The reinforcement pads are then contoured to match the bell halves.
So again, with 5-minute epoxy, I think what I did was I made an impression in here. And so I take these little bell halves and I take probably a clay modeling tool like that. And I stick it down in there. And I take my modeling tool and I form it.
You're just giving it the shape.
I'm giving it the shape. Yeah, that's all I'm doing. And I take it out, and hopefully it's about the shape of that bell half. So again, I have no idea how Richter did that, but that's how I do it.
We then clean the reinforcement pads in a pickling solution.
All this stuff has to be cleaned before you can solder on it. I've got my little crock pot. I start off with a quart of water and a Pro pickle in there. And it's a crock pot I can heat up. So I'll drop these down in there, but it just cleans them.
We then tin the reinforcement pads with a silver solder.
And one of the things that took me a long time to figure out, something that the solder doesn't stick to is liquid paper. Not sure how I figured that one out. But I'm gonna put a little bit of liquid paper right there.
You put it on the
I put it on the underside. So this is flux, silver soldered flux. And it's a paste, and the water quickly comes to the top, and you can keep adding water. I need to add a little water to this. I'm gonna get a little water and I'm gonna add a little bit. You gotta, because the water evaporates off of it over time. This is what makes the silver solder stick to the metal. And I'm gonna paint this thing all around that. And it can dry. It's okay if it's dry. And then I'm gonna put a little dab of solder on there, and it's called tinning it, and it will, so the whole back side of this thing will be covered with silver solder. And I use what's called easy. They always put an E on it. It's called easy solder, but it's got to be at least, I think it's 45% silver or something like that, or your bell will be a dud. You can get harder stuff, but I found that this easy solder is just about right. So now I'm going to grab these little reinforcement pads, and I'm going to grab them right there on the liquid paper so it doesn't stick. Otherwise, I would solder this to that.
Right.
And it would be a real mess. All right, so now you can see that little piece of solder is right there. I've got my flux covering it. I've got a little piece of solder. And I'm gonna heat this thing up. And that solder is gonna melt. Get it red hot, and now the whole thing has got solder on it. And then I can, because I've put that on the liquid paper, I can get it off of there. Again, if that flux wasn't on there, it wouldn't stick. There's a little spot right there, but I'm not worried about that. So there are your 4 little pads.
Next, we re-clean the pads in pickling solution.
So now I'm putting it back in there to get all the flux off of there. Put a little flux right here on that pad. Solder's already on the pad. It doesn't need solder on both pieces. It just needs it on one of them. So I'm going to stick it on there with that flux. And then I got another tool. I got these clamps like that. They go like that.
Does it have a name, or is it just?
No, I have no idea. I got all this stuff at and we got a jewelry supply store here that has all these tools in it. So it's very, very handy. That's where I buy my silver solder, and I buy most of these tools and stuff like that. I'll take this tool, and this will really hold it on there right there. So I've got it clamped on there pretty good.
Mm-hmm.
Then I put it in my little holder here. Now I'm gonna fire up my propane torch again. There's some science to this. In other words, you can have a real big flame, or you can have a little bitty flame. In this case, I've learned that what I'm trying to do is there's solder on the back of the pad. So I want to draw that solder from the pad onto the bell half. Mm-hmm. And to do that, I'm not going to just heat directly on that pad. I'm going to heat it up here and around here, and that'll draw the heat that way. So I don't need a real high flame, but I'm going to do it up here. Again, that's just experience. I'm going to do it up here. You can see it starting to heat that. But you'll be able to see, here it starts going now. See it drawing that flux?
Yeah.
You can almost see the solder. and then I kind of work my way into it, so I'll make sure that it's good and melted right there. And now we're going to get our template out that we made, this high-tech template. And we're going to put the bell half on there. It's pretty amazing. The human eye. I've tried to make fixtures. I'll show you. See, I try to cut grooves in here and line them up. The human eye is actually closer. I mean, it's you can tell when it's off and when it's on if you're real careful. So I usually line this up as close as I can get it. Put more flux on there. Scoot that over. If it looks off, it probably is off. If it looks on, it probably is on. It's close enough anyway.
Silver solder makes smooth fillets around each reinforcement pad.
My little reinforcement pads aren't always just perfectly. This one's pretty good. It's, conforms to the pretty well, but if it doesn't, I'll just take such thin metal, I'll kind of squish it down to make sure it conforms. But as you can imagine, even though we tried to get as much silver solder as we could around there, I'm sure there's some areas
that aren't adhered.
Just been trial and error over years and years and years. This isn't totally necessary, but I like to do it. It keeps me from the solder from running everywhere. Again, solder doesn't like liquid paper. And so I've kind of learned to put a circle of liquid paper right there to contain the solder from just getting out of control. It's not a big deal, but it's important to me. What I want to do, like last time when I was doing it, I was heating it out here away from the pad. Well, I'm going to do just the opposite this time. I'm going to do a little flame, but I'm going to apply it just to the pad because I want it to draw the solder into it, not away from it. So I'm going to start heating that pad up, and you can see that flux starts getting real liquidy looking, and that's how you know when it's ready. So it starts turning red now, and I'll touch that solder right there, and it's just running down in there. And it just follows that. I don't want too much, and I don't want too little. Let me look at it here. No, I don't think I got enough. A little better.
Holes are drilled in each reinforcement pad and will guide where the slit is later cut, thus protecting the bell from cracking with use.
All right, I'm going to center punch where my hole's going to be. And then I'm going to take my Dremel tool. These are my starter holes. I'm drilling the final hole.
Then we re-clean the bell halves in pickling solution. In step 4, we join the two halves to make the completed bell. First, we choose the bell's clapper from either spherical or hexagonal stock.
So what do we want, hex or balls? Let's do hex. Here's a grand bell that Winder gave me. Yeah, it has been used, but it's got a ball in it. It's pretty loud.
Yeah.
But it doesn't, it does roll rather than, that's hex. I think hex does a little better. So we got 2 tops and 2 bottoms. Now here's a fixture I got from Vic Hardiswick that I've continued to use. Again, his uncle was a tool and die maker, but it's very handy. It's to hold the 2 bell halves together, and again, these are non-metallic, non-conducting, like asbestos or something. So it's a real sweet little deal there. I'm gonna sand them until I get a nice clean. You can start to see an edge there, a flat edge. That half has got a nice flat edge now that I've sanded on it.
We align the top and bottom halves so that the BWHIT holder holes are 90 degrees from the reinforcement pads.
They're holes for the BWHIT. You want them to be opposed. So our reinforcement pads are here, and you want these holes to be opposite. In other words, the pads are here, your holes are here. The water evaporates off of this flux, so every once in a while you have to add a little water. It's water soluble. Make it into a nice fluid paste. Again, the solder won't stick anywhere that there's not flux on there. Now we're going to align the 2 bell halves. And you want the BWHIT holder perpendicular. And I'll mark it so that I know if it moves. It moves around a little bit. So I'll put it right back where it was. Looks good enough. And we'll put it in my fixture.
With the bell held together in fixture, we apply soldering flux 360 degrees around the bell waist.
And then you start applying that flux right in the crack.
We solder the bell halves together using silver solder.
Got my easy solder. I'm going to dip the end of it in the flux as well. And I'm going to snip off a little piece. Put it right up here in the top. Propane torch. Start heating this bell from down below. I'm not going to apply the heat directly to the solder. I want to draw that solder down. So I'm going to heat down here. You can see the flux becomes translucent and the bell's getting red hot, and soon the solder starts to flow. There it goes. Now I'll turn the bell. Again, heating from down below till the solder starts running. Gonna make sure the solder is all the way around. And then you can make the solder a little more evenly. You can see that it's running through down that groove and evenly distributed. That looks pretty good until it's all even. Put it on a non-conductive pad and let it cool.
And after the bells cool, we re-clean them in pickling solution. Now, it's time to give the bell its voice. Jim uses another custom fixture to cut the slit in the bottom half, which allows the bell to ring.
So I will line these holes up as best I can. Now I have my slot cutting tool, and sometimes you have to make little adjustments. I have to eyeball it and make sure that it's going to hit right in the middle of the hole there, and make sure it's going to hit the middle of the hole there. And if it's not quite right, and this one needs a little adjustment, that's not really it's important, but it's just one of those little adjustments you gotta make. So it looks pretty good there. After I've made all my adjustments to the bell half to where the cutter lines up with holes on both sides, now I'm ready to cut the slit using this fixture. I think it looks good.
Richter typically used brass or bronze rod to form the beewood holders.
Put these beewood holders down in the pickle so that they are nice and clean.
We then insert the beewood holders into the bell top halves and solder them in place.
Pretty much the same size of the hole, so it takes a little forcing to get down in there. A little bit on the beewood holder, a little bit on the bell. Both parts have to be hot. Soldered.
The nearly completed bells receive a final bath in pickling solution.
We got everything done. And we're ready to start polishing.
Step 5. Finishing the bells. First, we inspect the bells and deburr where needed.
I usually start off with these Scotch-Brite bristle discs. It gets most of the fire scale off.
Then we pre-polish with fine steel wool to clean the surface.
Gives it a nice satin finish, but it's certainly not polished.
Lastly, we polish to a high shine with a good silversmith polish, also known as rouge, such as Haggerty or semi-chrome polish.
For nickel, they recommend this green rouge, green high gloss for nickel silver. But I've used that for years, but I kind of like this Zam, which I think does a little bit better job. They both do a really nice job of doing the final polish. All right, these Richter bells are pretty much done. The only final step I would do is clean them with an ultrasonic cleaning solution and a little vibrator. But these are basically finished falcon-sized bells.
In a tradition spanning thousands of years, falconers have followed the sound of bells to connect and reunite with their birds. Today, thanks to master practitioners like Jim Ince, and to your support of the Archives of Falconry, that tradition may live on for centuries to come. We thank you for watching this inaugural episode of the Archives of Falconry's Masterclass video series.